Good day, everyone, and welcome to the October Pacific Northwest DEWS Drought and Climate Outlook webinar. Thank you for joining us. I'm Holly Prendeville, the coordinator of the USDA Northwest Climate Hub. This bi-monthly webinar series is hosted by NIDIS, the Northwest Climate Hub, and CERC. It is designed to provide stakeholders with stakeholders in the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climatic events, and also includes discussions of observed impacts and other relevant updates from across the region. This webinar is being recorded, and the recording will be posted on drought.gov later this week. Note, after today's webinar, you'll have an opportunity to provide us feedback to help us improve this webinar series. So please take a moment and tell us what you think, and also suggest any speakers you would like to hear from. So today's speakers include, we were scheduled to hear from Kelsey Jensko, the state climatologist from Montana. However, the copious amounts of snow that Montana has received, along with the frigid temperatures, has not allowed him to be able to make it to the webinar. So with this, I'll give you a public service announcement and make sure everybody has chains in their vehicle anytime there's snow in the forecast. And with that, we'd like to thank Nick Bond and Karen Bobacco from the Office of the Washington State Climatologist, who will be serving in his place on very last minute notice. So thank you for that. And Nick will be presenting climate recap and current conditions. Then we'll hear from Mike Halpert from the National Weather Service Prediction Center, who will present the climate outlook. And then Rob Langston from Langston Consulting, who will give us an overview of FuelCast.net. And then finally, we'll hear from Sonia Hall with Washington State University, who will talk with us about a series of videos and case studies on rangelands resilience in the Northwest. Please use the chat box to ask any questions that you have. And we will get to a question and answer period after all of the presentations. Before we start the presentations, we'll just briefly highlight the partners that help make this webinar series happen. The Northwest Climate Hub delivers and develops science-based, region-specific technologies and practical information that assists agricultural and natural resource managers with climate-informed decision-making. We also are co-hosted with CERC, the Pacific Northwest Climate Impacts Research Consortium, is a climate science to climate action team and supports policymakers, communities, resource managers as they work to adapt to a changing climate by transforming the latest climate science and data into usable knowledge. Now I'll turn over to Britt Parker, who will give us a brief overview of NIDIS.
Thank you, Holly. NIDIS's mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We want to improve our understanding of how and why droughts affect society, the economy, and the environment, and to improve accessibility, dissemination, and use of early warning information for drought risk management. NIDIS's approach to achieve that goal is to build the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ across the regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their regions. The Pacific Northwest DEWS was officially launched in February 2016, and our strategic plan is available in on drought.gov. And I'm very pleased to let you know that the newest version of our strategic plan is with our layout artist and should be available with the relaunch of drought.gov, which will occur on December 1st. And so we're really excited about the new website and hope that it's very helpful in accessing drought information. So mark your calendars. We have a lot of upcoming events. The Oregon-Washington 2020 Water Year Recap and 2021 Water Year Outlook meeting will be later this week on October 28 and 29. The 2020 Idaho Fall Water Supply Meeting will be next week on November 5th and 6th. And Heidi, I think Holly is putting, the registration links in the chat box. And then our next webinar is a little bit early in December 14th, due to the holidays. And so all of these, you can find more information on the calendar on drought.gov for all of these, and links in the chat box to register. Finally, to facilitate our early warning system, more precipitation observations are needed. We encourage you to join COCOROS, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as condition reporting. Observations by COCOROS observers of precipitation events or the lack of precipitation are important events to capture and improve our understanding of weather. So if you are interested to become a volunteer or to learn more, please visit cocoros.org.
Thank you very much, Britt. Now we will hear from Nick Bond, and again, many thanks from Britt and I to Nick and Karen for stepping in at the last moment to give us this presentation.
Yeah, thanks. And yeah, I'm happy to be able to step in. And of course, now they owe us, and so that's a good thing. I trust everybody can see my title slide, Regional Climate Conditions. Okay,
yes,
great. So let's go. And here, I just would like to start off with reviewing the summer, last 3 full months of July through September of this year. Here are maps on the left of temperature and on the right precipitation in terms of the departures from normal in degrees Fahrenheit, and for temperature in a percentile sort of representation for the precipitation. And you can see that much of the Pacific Northwest was warmer than normal. And almost all of it was drier than normal, with Western Washington being kind of the exception, and basically because of some rains in September. Looking at a little bit, closer to recent times, the last 60 days, get a somewhat different perspective there, where again, warm across the entire Northwest, and 5th warmest on record, actually. And so almost 4 degrees Fahrenheit, that's a pretty hefty anomaly. And precipitation, wet in the north, dry in the south. And that same kind of pattern is replicated here if we just look in the last 30 days, especially in terms of precipitation. And here for temperature on the left, much of the same with Montana, especially east of the Continental Divide, now checking in with cooler than normal conditions, with especially recently some very frigid temperatures there. All right. From a kind of hydrologic point of view, the map at the left shows the total moisture that in most places this time of year is soil moisture in a percentile representation, and with the reddish brown color showing where it's considerably drier than normal. A few patches of green where we've gotten some decent precipitation. The stream flow relative to normal, a 28-day average, is shown at the right. Not a tremendously meaningful variable, I would say, this time of year, where stream flows tend to be kind of lower before the fall rains really have started. But one thing that I guess is kind of encouraging is that there's a lot more kind of green and bluish dots there, indicating normal to above normal stream flow for this time of year. All right. That being said, there are some watersheds that are in pretty rough shape, and I looked around just in the Bureau of Reclamation, their different watersheds, and in particular in the southwest part of Oregon, the Rogue River Basin you can see many of those reservoirs are basically close to empty. Now, this time of year, they're generally quite drawn down anyway, and I'm not sure exactly how much they typically have this time of year, but some of these are basically glorified mud puddles at this point. And so there's some room if we get the precip. One thing that's kind of interesting, because this cold weather we've had just recently, with Spokane having 7 inches of snow over the weekend, and especially the eastern part of the Pacific Northwest getting cold weather and some snow, is that the SWE in terms of the percent of normal for this time of year is quite a bit above normal in some places. Of course, this isn't a lot of snow, and it's not so meaningful, but still kind of, I think, kind of interesting. All right, let's go back a little bit to last month and the nightmare that was the hot, dry weather and the strong east winds that sparked all those forest fires. I thought it'd be just kind of interesting to review a week here during the kind of height of that event for Oregon, with a huge ridge of here at 500 millibar geopotential heights along the west coast. At that time, there were some record winds from the east over northern Oregon that helped fuel those fires. At a while there were some, this shows where there were the active fires there in September, and some of the areas in which were under various levels of evacuation orders and so forth. And what is truly remarkable was the extent of the fires on the west side of the Cascade Crest in Oregon, and with all the poor air quality as a result. Here's just I have better access to some of the satellite photos just over Washington State itself, and this just shows how horrible the air was during that event. And just to sum up here with the Drought Monitor map, the one from last week, here, rather than just the Northwest, I want to give a little perspective by showing the West as a whole. And while there is still extreme drought, D3 in Oregon, and a little bit snaking into the south central part of Washington State, at least we're doing better than the kind of other parts of the West. Colorado and Utah, there's some regions with exceptional drought. Colorado is getting into the act with its big fires recently and so forth. And so while we've had some problems, there are other parts of the West that are also having some big problems. And so just to summarize, again, belaboring the obvious perhaps, but we've been on the warm side from most of the Pacific Northwest the last 3 months or so. Generally light precipitation. More recently, there has been some decent amounts in the northern part of the Pacific Northwest, and has kind of basically, I would say, ended the fire season for that portion into Montana. But there are still large areas of the Pacific Northwest that are remain in extreme drought, especially in Oregon, and are of concern. And we're next going to hear from Mike about how this winter is liable to shape up, and who's going to get better and who's kind of at the threat of remaining under kind of dry conditions. So with that, thanks.
Thank you very much, Nick, and good luck with your interview on NPR. Folks, you may hear him later today as he gets interviewed. Next, we're switching to Mike Halpert, who's going to give us the climate outlook.
Thank you, and hopefully you can hear me and see my screen. My title slide talks about climate factors for this winter. The reality is, given the recently developed La Niña and the expectations for it to continue, that's largely the factor we really expect to shape and drive the upcoming winter. So in terms of where we are, and again, I'm not sure my audience here, so just quickly, certainly La Niña refers to conditions across the tropical Pacific Ocean. La Niña is the cold side of things. As we go through, we'll see that in some of the figures that I'll show, and also discuss briefly why we pay such close attention to it, and you know how it oftentimes will relate in impacting the winter. That La Niña developed officially during the month of August. We saw a gradual decrease in sea surface temperatures throughout much of the spring and into the summer. The ocean has continued to cool since then, so now it's you know, getting fairly impressively cool, so that we're looking to have a stronger event maybe than we initially anticipated. In a general sense, the stronger the event, the more reliable the impacts are, so that probably gives us a little more confidence in our forecast. We're already seeing the circulation in the tropics and actually at times even into the extratropics that are consistent with La Niña. Some of the figures that Nick just showed, particularly the recent ones, I was looking at the last couple of weeks of observations, and you know, very much is particularly on the northern tier with what we're expecting to see for this winter. And then the last bullet there, you know, we have La Niña, and you know, an 85% chance is pretty high in the climate world for a forecast. So we certainly expect that this event will continue through the winter and well into the spring. So this is a map of ocean temperatures across the Pacific Ocean, the subtropics and the equatorial zones. That red box in the middle is the area that we focus on. It's called Niño 3.4. Why it's called that isn't important, but that's the area that seems to have the greatest impact on eliciting an atmospheric response. It's, you know, this shows roughly the last month. I guess these are slides from last week. Didn't get a chance to update them this morning, but still, this is the very typical La Niña pattern with cold temperatures or below average temperatures from the South American coast, which is over on the right of the plot. In this case, extending even to the west of the international dateline, and then what we call this horseshoe pattern of above average sea surface temperatures from the North Pacific extending through the West Pacific and then back into the South Pacific. I mentioned that blue box, and so these are we have a few other boxes across the Pacific. Again, that box on the slide, that Niño 3.4. Recent value of minus 1.4 is approaching our notional threshold for a strong event. But for us to characterize these things, we're really looking for some level of persistence. This again was last week's value. This week was also minus 1.4. So certainly well greater than the threshold for La Niña of minus 0.5. We've been there, if you look at the second plot down on the right, since, you know, largely in the month of August, and it's continued to decrease. Really, actually, if you go back all the way to late June, it's fairly steady decrease in sea surface temperature anomalies through the current period. This is now looking at snapshots at below the surface. So the other couple of slides looked at just what was on the surface. This is now the top of each of these individual little plots is the surface, and then it goes down to 300 meters depth. Not a whole lot to take from this, except that this is, we look below the surface because oftentimes it leads what's going to happen at the surface. Really, it's the surface that's interacting with the atmosphere and setting up patterns that will impact the weather over North America and really around the globe. The important thing here is that the pattern has become quite stationary. If you look, you know, down along the right, you'll see that largely that areas of blue are in very close to the same location, and the areas to the west are staying in yellow. So as long as we see that stationarity, there's really no sign that we started to advance towards what we call the mature phase, which is what you see before things start to wind down. So certainly the typical evolution of this would show up in over a couple of months to see that pattern. And right now things are quite persistent across the Pacific, and that's what these forecast models show us. A bunch of different models here. Important thing is if you look kind of at where I've circled things, I won't go into what all the different models are. The horizontal red lines give the notional minus 0.5. So any forecast below that line is forecasting a continuation of La Nina. And for the most part, all of the models are well below that threshold, at least through the winter. A lot of them stay there, into the spring before we probably break out of this sometime during the spring or later part of spring. So again, very, very confident that this La Nina will persist and impact winter climate. Finally, this is our own model that we run at the Weather Service. I show this actually just because this is looking at roughly a bunch of different ensemble members, or it's a bunch of different members that are run out, and we typically see some degree of spread in the models. If you look at all the little lines on the left plot there, even for DJF, I mean, the bunching of these lines is impressively tight. You're still out however many months, 3 to 5 or 2 to 4 months from now. And they really are all between roughly -1.5 and -2. So anyhow, a lot of confidence that this event's not going anywhere. This is the official CPC outlook that's done once a month. So this was done back a few weeks ago. And again, with very high confidence, that 85% that this will last through the winter. So what does that mean in terms of temperature? The simplest way to understand what it means is to look at history. So look at prior events. If you see down at the bottom, it says there's 22 cases. So going back to 1950, so roughly over 70 years, 70 winters, we've seen 22 La Niñas. The figure on the left gives you, if you just average all of the departures from normal and then you combine it with temperature trends, there's what you get. So you get a largely warm south and east coast and below average temperatures in the northern plains extending back into your part of the world. The figure on the right shows how reliable that signal is, or the frequency of those 22 cases. So the cold signal is actually, pretty good, certainly above 50%. Parts of Montana are above 60%. When some of the areas that we would have much less confidence in are like if you look over California, where there's a slight warm signal, but it's not a particularly reliable signal. And you'll see when we get to the forecast that we don't pay all that much attention when we see kind of a conflict like that. For precip, the composites, again, a similar type plot, except that it's certainly a lot noisier. But it does show, in a general sense, a tilt towards wetter than average conditions in the Pacific Northwest and largely across the northern tier of the U.S. And again, the reliability, though, the one thing that we do pay attention to here is the drier signal, particularly along the Gulf Coast from Texas and then maybe into the Southwest, is a little more reliable than the wet signal across the north, although there are some indications that the Pacific Northwest is maybe not a bad signal in terms of that, and not surprisingly, that's kind of the La Nina pattern kind of shifts the storm track further north, resulting in a dry south, and so the area most likely to be wet with a storm track like that would be the Pacific Northwest. We also look at a suite of model forecasts. This is what we call the, actually the word national is not right anymore. It now should be North American Multi-Model Ensemble. We have some Canadian models in there. For temperature over the CONUS, a lot of reds. These models all do have CO2 forcing as part of that, and so it becomes challenging oftentimes to see blue on these maps. Now we do actually have tilts toward below average temperatures in Alaska and parts of Western Canada. three panels here. There's kind of a mean anomaly, same as we saw in the other composite. It's just the average anomaly over all the different ensemble runs. The probabilistic forecast is strictly a percent of members that fall into one of the three tercile categories. So again, while we're more confident for the warmth, maybe in Texas than in Washington, it's still, this would argue for warmth. And then the figure on the right is kind of adjusted for historical skill. Precip is maybe a little more interesting for this. Again, it's very similar, and it shouldn't really be surprising that they look, at least at a first order, like the composites, as the reality is that these models are all forecasting La Nina to continue, and I think when climate models are developed, if they don't get the typical teleconnections we see with El Nino or La Nina, they kind of go back to the drawing board and try and figure out why not. So, again, the dry south, the wet north. Here, the signals in the Pacific Northwest are fairly robust. In terms of the middle plot shows the probabilities are, probably 50 or 60% chance above. And even again, when we adjust for skill, you'll notice like if you look at the dry signal is a little more skillful than the wet signal to the north. And so when you get to the adjustments, maybe a little more of the dry signal is maintained across the south than the wet signal across the north. So the forecast, and I always start with temperature, even though this audience maybe is more interested in precip. But here's a case where we certainly are kind of going against the models, at least across the north, where we are favoring below average temperatures in the northern plains, extending back. And one of the important things for these forecasts that folks need to understand is the confidence and the skill of a climate forecast. It's much different than a weather forecast. So where we can't guarantee any of these results, and so what you see here are tilt in the odds towards one of three categories. The warmer signal across the south has more confidence. So I've got kind of a helpful hint towards West Texas, where that whole band has a greater than 60% chance. You can see there still is a slight chance towards below. I mean, 1 in 20 roughly, 1 in 25. So the below average temperatures that we favor across your area is far less confident than that, and some of the area is actually what we call equal chances. So that's basically, there's no tilt in the odds. And again, a lot of the uncertainty has to do with exactly where jet streams will set up, and then how persistent they'll become. I will say that again, looking at the last couple of weeks, the observations are very much like the winter type forecast. Maybe not quite too much below into Washington, but certainly the cold area is starting to show up in the northern plains and Montana. It's early for this, and so I don't know that I would expect that, the pattern is here and it's going to persist. But it is maybe comforting a little bit to see that given the forcing out of the tropics, that we are starting to see what we expect to see, especially as we get into winter and then throughout the winter. Here's the precip outlook. So again, I mentioned, the tilt towards below in the south and above in the north. Again, the probabilities in a general sense are higher for the drier signal. And that really largely is determined by, again, we're confident that we'll see a northward shifted jet stream, but, exactly how far north, is still to be determined. But shift it north at all, and you largely end up with most of the southern tier of the U.S. drier than average. And then finally, the drought outlook. And again, just to be careful here, this one product, all the maps I was showing were for December, January, and February. The drought outlook does not go out quite that far. So these go out only through the end of January. But in general, really everybody that's on this call, those areas, we do see either at least improvement and some areas where we would expect that the drought would be removed coming up. These products will all be updated, I believe it's November the 19th, assuming things continue as we anticipate them to. Certainly the drought outlook then that would go through February, we would likely see even more removal. Certainly D3 is pretty severe drought, so that will take some doing, but of course this is also a wetter time of year, so above average precipitation could result in that. So just a quick summary. We have La Niña. It's present. It's pretty well developed. It continues to strengthen a little bit, so we're very confident that it will persist. It does favor a northward shift in the jet stream and the storm track, which should result in above average precipitation in this whole region, which then should lead to improving drought conditions. And I will cede the rest of my time if I had any.
Thank you very much, Mike. Next, we'll hear from Rob Langston, who will tell us about FuelCast. And I'll remind you to put questions for our presenters into the question pod or the chat box, and we will get to those at the end of all the presentations. Rob, can you change your display settings? In the upper left-hand corner, we're seeing your notes and everything. And I think you may be muted as well. That looks good.
Hi, can you hear me now?
Yes.
Okay. Sorry about that. New platform for me to present on, so that's always fun. My name is Rob Langston, and thank you for your interest in FuelCast.net. Thank you also to the other panelists. It's been really informative so far. My name is Rob Langston. I'm a consultant with the U.S. Forest Service. I'm a software developer and data scientist. I work very closely on FuelCast.net with Dr. Matt Reeves, who works with the Rocky Mountain Research Station. He came up with the idea for the rangeland production monitoring service, and I helped him bring it to life. The goal of this presentation is to give you a very quick overview of the FuelCasting system, and then we'll actually take a look at the performance over the past growing season and how we were projecting conditions on the ground. The problem is that right now we, at least in our minds, we have trouble accounting for interannual variability in rangeland systems in terms of emerging climate conditions and their effect on what the growing season will look like, both in terms of magnitude of production, but also in terms of when the peak of season will occur. We're looking for, incorporating some of the things we've already seen so far in this webinar, but those drought monitors of the conditions we're at now, and then projecting what the effect will be on the ground. The rangeland production monitoring service has two main components. The first is a retrospective, and that's a 30-meter continuous CONUS data set that goes back to 1984 annually, which gives the maximum annual 1-hour pounds per acre for rangelands, but then also the day of the peak of season on which that occurred. The other component is FuelCast.net, which is what we'll be talking about here, which is basically estimating what that production will be this year, given current climate conditions. We make weekly projections of fuel and forage near real time, and I'll speak some more to that in the next couple slides. But we ingest eMODIS for an NDVI product. We incorporate GridMet for precipitation, and for drought we use EDI, which we find is a nice continuous variable that's useful for prediction. We start casting about 4 months prior to the peak of season from the mean from that retrospective product that I mentioned. And we use eMODIS over just standard, mod 13 because it's much more timely in its release. Sometimes we were waiting on MODIS, for a month and a half with eModus, we can be projecting on data that's only a couple weeks old. The other aspect of FuelCast that's not just the magnitude of the peak of season, but it's the temporal component. When will it occur? If we're seeing dry conditions, it could happen, the peak to happen sooner because it won't achieve the magnitude that it has in other years. Of course, the converse is true as well, such that wet conditions late in the growing season could push the peak later. So how do we accomplish this? We have a machine learning process that every week we take a sample using Google Earth Engine of about 1.5 million locations across the Western US. We do some data engineering and feature engineering, clean up that data, and then we use AI platform, Google Cloud Platform's AI service, to build a model and project then the peak of season, both the day and the magnitude in pounds per acre for the Western US. From that product, we can derive several useful data elements that we think our users are interested in. The first is the actual 1 hour yield itself. The next is the yield compared with normal. So we take that stack of from 1984 to at this point 2019, and we just say how different do we think the fuel yield is going to be this year than it's been other years. We also tease out the herbaceous component on its own, and then likewise do a comparison with the mean. We have the projected peak of season, and that's just a Julian day from 1 to 366, and a deviation for that as well. And then the last derivative product we do is actually an updated surface fire behavior fuel model. So the FPFM 40 product. We take Landfire's 1.4's FPFM 40. We take our projected fuel loads, and then we update the rangeland areas based on our projections to have the fire behavior fuel model that uses the amount of fuel that we think is actually there on the ground now. And then lastly, a sort of meta-analysis. We provide the trend of our own projections. As I said, these are weekly projections. And 1 week of sub-normal precipitation probably won't ruin a system. However, if that keeps happening, our projection is going to take a more drastic reading of the situation, and it will start pushing that projection lower. So we have the trend of our projections to show, this is a continuing situation. It continues to get worse, or maybe continues to get better, depending on your management objectives here. So let's look at what we observed in 2020. We started FuelCasting in March of this year, and almost right away, we were seeing situations in the Southwest that saw much increased vegetation growth that could potentially lead to, a big fire season, which of course we've seen that in the Southwest this year, a very big fire season. Now on June 9th, we were also seeing that there are some declines in production signal from probably from drought. And in particular, you see that circle here in Moffat County in Colorado. We're seeing a very big decrease in production. So in July, Matt, the scientist behind all this, he started doing a podcast, about a monthly podcast where, he called it Reading the Tea Leaves. You can find a link to it on our site, fuelcast.net. And he said, we're seeing this huge decrease in Moffat County. Be prepared for a pretty devastating decrease in production compared to previous years. And, we shared that with some people, but rightly so, they don't believe some new outfit saying that their system is doing something that they're not seeing. That's exactly the problem we're trying to solve. We're trying to provide a quantitative outlook rather than a qualitative one. And sure enough, wouldn't you know, about a month later, more people were calling it, and it was designated a primary natural disaster area due to the conditions on the ground. So who we want to use this? Fire planners, of course, having almost real-time fire behavior fuel models on the ground would be a huge win for firefighting. Other predictive services, there's the idea that you could use our product to then, create more derivative products based on the potential yield of the system in the year, and couple that with other climate models to maybe have a longer view of what the landscape's going to look like. We're already working closely with the Farm Services Agency on some special provisions they have in terms of generating policy and managing insurance claims when it comes to the effect drought's having on farmers. We're also working with producers and range managers, particularly in the Southwest, to help them better manage their stocking rates and their herds on the grazing lands. You can go to the site. It's, as I said, FuelCast.net. There are 2 prototype apps up right now. One is just a general view of the last FuelCast we made for the year. At this point, we kind of think that the peak of season has been achieved in most areas across the Western US. So we're taking a little break to spruce up our interface, make a more robust app, and get ready to start in January of 2021 for the next growing season. There's also the FSA app, which was a proof of concept that we aggregated our 250 meter pixel projections into spatial aggregation that they wanted for their own decision making. So I know this has been a really fast presentation for the amount of things that we're doing. So we're always looking for partners for the 2021 growing season. Please reach out to us if you have questions, or if you're interested, or if you have concerns. And either Matt and I will take those questions. So thank you.
Thank you very much, Rob. And I've added links to the tool in the chat box. Next, we'll hear from Sonia Hall. And again, if you have any questions, please put them in the question pod or the chat box, and we'll get to them at the end of the presentations.
Thank you, Holly. Can you hear me okay, and can you see my presentation?
Yes, on both accounts.
Thank you. Well, thank you, everybody. What I'm going to talk about is different to what you've heard so far, but I'm going to share some of the work that we've done over the last few years looking at ranchers across the Pacific Northwest and work they're doing that contributes to rangeland resilience in the face of climate change. To get started, I just want to acknowledge that the work I'm going to talk about is the work of a team of folks. These are my co-authors on the case studies. We also had a couple of videographers from Washington State University who developed the videos, and I'll talk a bit more about that. But primarily, I'd like to really highlight the ranchers who were willing to work with us and share their stories, which are the basis of these case studies. So why did we develop case studies? This builds on an effort that has been ongoing at Washington State University looking at farming practices, and this project in particular expanded that to ranching situations. But the 2 big reasons why we are developing these case studies is, first and foremost, farmers and ranchers, they are experienced at dealing with risk, whether it's environmental risk and the kind of interannual variability that Rob was talking about, the kinds of changes across years that we're seeing, as well as a variety of other risks, including markets and so on. And so they're well placed to really incorporate the risks that are posed by climate change into their decision-making processes. And then the second big reason is that we understand that peers and what other ranchers and other farmers in the area do and how that works out for them is an important source of learning for farmers and ranchers. So being able to build from what their peers are doing. Because of that, our focus was on, are there win-win strategies that are working right now for some ranchers in terms of their current operations, but that also confer elements of resilience that can set them up better for future changes in climate. And this is the basis for sharing these individual success stories through these case studies. So how do we tell these stories? What are these case studies? Basically, they're multimedia case studies where each case study has two components. The first is a short video, and those range from about 7 to 10 minutes that are based on interviews with the ranchers themselves and narrate the story of the components of their operation that really contribute to resilience in light of climate change. And then the second is a more in-depth look at these operations through extension fact sheets, where again, the core of the fact sheet is that narrative of what it is that these farmers do, what challenges they face, what benefits do they see. But we also pair it with what we call science sidebars. So these are brief summaries of the science and the sort of ecological understanding that supports the kinds of practices that these ranchers are implementing and why we consider them examples of ways to improve resilience in light of climate change. So I'm going to very quickly run you through some of the highlights of the 3 case studies that we developed for ranching operations. The first is Russ Stingley, who has a cow-calf operation in central Washington state. And he actually manages his operation through a coordinated resource management plan that was developed with a variety of stakeholders, and it is designed to simultaneously achieve multiple use goals. And these are not only production goals for his operation, but also habitat goals and fuel reduction goals. So some of the key components that this grazing plan incorporates are the use of conservative stocking rates, a focus on the native perennial bunch grasses in the rangelands that he grazes to ensure that they have the opportunity to go to seed every other year, a focus on minimizing the grazing events that happen during critical periods of the phenology of these bunch grasses to help them thrive. And then limiting the grazing duration in a way that allows these rangeland plants to grow actively without being grazed for a significant component of that growing season. So as I said, the fact sheets go into a lot more detail on this. But the point I want to highlight is that Stingley's approach really focuses on the health of the rangeland vegetation. And these are shrub steppe systems that, when they're degraded, are likely to be invaded by species like cheatgrass, which favor more frequent fires in these areas, and fires is one of the disturbances that is of concern as the climate changes. And so that focus on rangeland health and maintaining the health of the vegetation provides some of these components that confer ecological resilience to his operation. The second case study that we worked on was the operation that Jack Southworth runs in the high desert of Oregon, south of John Day. Jack has developed or manages under a sort of holistic management approach with a real focus on not only rangeland health, but also the health of the soil. And he has some interesting components to his operation that provide flexibility, and I'll touch on here in a minute. So again, some of the key components that are captured in the grazing plan that Jack uses is his grazing operation, which includes both his private ranch, but also leases on Forest Service lands at higher elevation. His management focuses on grazing at high densities, but with frequent rotation. He uses plant phenology and makes decisions on when to start grazing based on the phenological stages of key plants. He has also identified areas within his private lands that have been notably degraded due to past grazing, and he has seeded non-native high forage production species in these areas to both increase the forage production, but also to improve the cover on the soil and therefore contribute to soil health. Jack monitors annually, and he explicitly tracks how his management approaches have impact on both the soil and the vegetation and how those respond. And then this component of flexibility that I mentioned, Jack's operation at its core is a cow-calf operation, but he has the ability to retain those calves and keep them through the yearling stage, those years that the forage conditions and the forage availability would support that. And so this ability to add a yearling enterprise in good years really provides some significant flexibility, which allows him to respond to the conditions any particular year. So again, summarizing Southworth's approach that is focused not only on some of those rangeland health components that I mentioned with the Stingley case study, but also this the diversity of grazing resources, including native rangelands, rangelands that have been seeded with non-native species, as well as the higher elevation lands that he leases from the Forest Service, conveys flexibility to his operation. And as I mentioned before, the ability to add a yearling enterprise in response to good forage availability years and not doing so in drier years when there's less forage availability gives him a flexibility that allows him to deal with risks and therefore also presents an opportunity for increased resilience as the climate changes and those conditions and risks change as well. So in addition to the ecological resilience components that the Stingley case study highlights, the Southworth's operation really adds this component or examples of operation resilience in his operation. The third case study that we worked on is the ranch that Brenda and Tony Richards run in Idaho, southwest of Boise. Their focus is really on building relationships and engaging with land management agencies. So they actually have quite a relatively small amount of private lands, and the majority of their livestock operation is based on grazing leases, and these are on federal, state, and private rangelands. And one of the reasons why we looked at their operation as part of these case studies is because we were interested in their ability to both respond to and recover from the impacts of the 2015 soda fire that burned approximately 95% of the lands that they normally graze. And so we delved into some of the components of these relationships that they have built and how those conveyed or translated to what they were able to do during the fire, where they managed or contributed to a network of people who were communicating around what the fire was doing and what values and properties were at risk, as well as participating in the fire response through their membership with the Rangeland Fire Protection Association in the area. That resulted in or contributed to the fact that no structures were lost in their valley during the soda fire. And then we also delved into some of the relationships that they have built over years with the land management agencies on the lands that they graze, and how that really helped them be part of the conversation and contribute to guiding efforts in post-fire rehabilitation. And this included things like investments that the BLM made in reconstructing fences that were burnt down during the fire, as well as decisions around where and what and how to carry out seeding operations for rehabilitation of the vegetation itself. And so in the Richards case, this focus that they have had, as I said, for years now, on community and the relationship that they have with land management agencies, not only help them recover from the soda fire, but really translates to these elements that confer resilience to disturbance and to shocks that the system might feel, but also to longer term trends such as those posed by a change in climate. And so this case study allowed us to highlight some of the components that determine the community resilience in an area. So to wrap up this presentation, I just wanted to highlight that what we have been looking to build through these case studies are examples of how individual ranchers are already implementing practices that convey some aspect of resilience and that would set the stage for improved resilience under climate change. And that includes components that have to do with ecological resilience, components that have to do with operational resilience, as well as components that contribute to community resilience. And the reason we're focused on this is there really isn't one recipe for increased resilience across the inland Pacific Northwest. And so this project allows us to really highlight how different cattle operations that face different challenges, that have the ability to use different strategies, all of them have examples of ways to increase resilience. And so with that, I will wrap up and hand it back over to you, Holly.
Thank you very much, Sonia. If there are questions, please put them in the chat box or the question pod. We have two related questions that are and there may be different answers for Nick and Mike. I will read them both. Can you clarify whether you use a shifting normal when reviewing historical departures for normal in La Niña conditions, for example, i.e., you're using a 30-year normal as a running mean or fixed? And then similarly, we are defining normal as a multi-year average 30 years in the first talk. This method may obscure the effects of climate change over time. Is there any discussion underway about the normal benefits, about the benefits of defining normal differently? Mike, would you like to start?
Sure.
Or Nick?
Go ahead, Mike.
Okay, so you're right that all of our products are issued relative to a fixed 30-year period. The current period is actually kind of old. Admittedly, it's 1981 to 2010. Next year it will update to 1991 to 2020. That's kind of the paradigm that is used to issue these types of climate outlooks around the globe. Actually, it's follows the WMO ideas and the way that we do these things. It has a bigger role certainly on temperature, where trends are stronger than precipitation. But that is a reality of the way we issue these forecasts. A lot of users of these products, I mean, they understand the base period we're forecasting relative to. If we were to update more frequently, I think in addition to resulting in more work for us to keep updating all of our tools and the whole process, it would probably create some headaches for some of our users as well, who, while maybe not ideal, at least can understand what the base period is that we're forecasting relative to and design all of their own models to that period.
Yeah, I don't have too much to add to that, except for it just kind of depends on the application, whether you want to include a climatology that goes, you know, the historical record back to the 1890s or whatever, versus the more of a 30-year period. And I think for a lot of applications, people want to know, what is this winter going to be like compared to the winters of this era? And that, you know, what happened a century ago is maybe not so relevant.
Thank you both. We are at the top of the hour. I don't see any additional questions. So with that, I'll thank everyone for joining us. Thanks to our presenters for their presentations. The recording will be available on drought.gov later this week, and PDFs of the presentations can be accessed by emailing Britt Parker. If you have additional questions, you can reach out to the speakers directly. Their contact information is listed here on the side. Please remember to mark your calendars for the next webinar, the 14th of December. We'll see you then, and I hope you all have a great day. Thank you.